Session 5, Disc 5. The cell, the battery, and electric current. It should be understood that the term battery represents a combination of single, individual cells connected together. When a load is connected to a battery, it causes an electric current to flow through the individual cells. The entire battery is being discharged. Batteries are designated as either primary cells or secondary cells. In primary cells, this discharging condition cannot reverse, making the cell inoperative. However, the secondary cell, also known as a storage cell, can reverse this discharging process, allowing the cell to be recharged. This is done by sending energy back into the cell. This allows the cell to be reused over and over. This is known as recharging. The recharging process is fully discussed when we discuss battery charges. The following animations and videos show the basic internal of a number of different primary cells. It should be understood that when chemical action inside these cells ceases, there is no current flow. The cell is inoperative and can only be recycled. The primary cell is a chemical energy converter. A chemical reaction inside creates electrical energy, which causes an electric current to flow inside a connected load. These cells come in many shapes and sizes. The zinc cell is one of the most widely used primary dry cells that was ever invented. The picture shows its basic construction. The basic internals parts are listed. 1. The metal cap. 2. The seal. 3. A carbon rod. 4. Zinc can. 5. Bobbin made of manganese dioxide. 6. Separator, the electrolyte. 7. Insulator. 8. Metal bottom. The chemical reaction inside the carbon-zinc battery generates hydrogen gas. The gas forms around the carbon rod. This condition is called polarization. Eventually the gas will insulate the rod from the electrolyte mixture, stopping current flow. To overcome this, a mixture of manganese dioxide is used inside the battery. It absorbs the hydrogen gas. The basic chemical action starts with the electrolyte, which is in a paste form, consisting of ammonium chloride and zinc chloride dissolved in water. The metal cap provides an electrical connection to the solid carbon rod. The carbon is not part of any electrochemical process inside the cell. The following text is to help explain some of the terminology used in the discussion of cells. In voltaic cells, the anode is the negative electrode, where the cathode is the positive electrode. This is because it has been widely accepted that all anode terminals release electrons, undergoing oxidation, while all cathodes terminals undergo a reduction. Also, negative ions, called anions, migrate to the anode, while positive ions, called cations, move to the cathode, where they are selectively discharged. The zinc can seal in the different parts of the cell. It also serves as the negative electrode and is called the cell's anode. The solid carbon rod is surrounded by a manganese dioxide mixture. It acts as the positive electrode, called the cathode. The rod is not part of the cell's chemical reaction. The separator contains the electrolyte in the form of a paste. It is because of this state that the zinc carbon cell is referred to as a dry cell. The metal bottom forms the negative electrode connection to the zinc can. This negative contact point is called the cell's anode. The molecules of the electrolyte form ions. The positive ions are attracted to the carbon and manganese dioxide, causing the carbon rod to become positive. The negative ions are attracted to the zinc can. These ions give electrons to the can, making it negative. Since the carbon rod is positive, a potential difference exists between the two. Shorting out the positive and negative leads causes electrons to flow. This flow is called electric current. The electrons only flow from the negative lead to the positive lead and is referred to as direct current. Modern-day batteries have evolved into an array of many different types and shapes. One of the most common is the long-life alkaline cell. The alkaline battery is a transportable source of electricity that converts chemical energy into electric energy. The following animation is used to show the basic construction of a typical alkaline battery. The cell's internal parts are 1. Plastic jacket. 2. Metal jacket. 3. manganese dioxide mixed with graphite, potassium hydroxide. 4. Zinc paste, mixed with potassium hydroxide. 5. Porous separator. 6. The plated electron collector. The cathode, the positive terminal, is made of a manganese dioxide graphite mix and the metal can case. The anode, the negative terminal, consists of a zinc paste and an electron collector. The cathode and anode electrodes terminate into metal caps at the top and bottom of the battery. The electrode sits in a paste solution called the electrolyte, made from potassium hydroxide. Ions in the electrolyte easily pass through a porous separator, which separates both electrodes. The chemical action begins when the battery is connected in a circuit. At the anode end, the zinc turns into zinc oxide. This creates free electrons that flow through the external circuit. The electrons return to the cathode, where they are collected by the manganese dioxide. The negative charged hydroxyl ions move from the cathode to the anode, completing the flow of charges. Another primary is the button-size battery, which is used in watches, camera, hearing aids and calculators. The anode is made from powdered zinc. The cathode is made of mercuric oxide. An absorbent pad, soaked with an electrolyte of potassium hydroxide, separates the two. Each type of the primary cell as discussed have certain advantages and disadvantages. The carbon zinc cell is inexpensive but operates poorly at low temperatures, losing their voltages sharply. The alkaline cell operates better at low temperatures, these are more expensive but last longer. The mercury cell is capable of operating at higher temperatures than the others. It is more expensive, yet it is very compact. The following video shows the basic internal construction of a few different primary batteries. It should be understood that the placement and chemicals used in each cell are well guarded among manufacturers. Batteries are designated according to their size and voltage. The cell below is a 1.5 volt D cell. It can supply up to 0.14 amperes. Here we see the outer casing sliced to removed, the plastic label and to expose the inside of the battery. The negative casing is the negative side of the battery, while the inner center core metal is the positive side. Here the positive lead cap is lifted to expose the insulating tube and washer that insulates it from the case. The insulating washer is pried away from the positive center lead of the battery. The metal casing is pried apart. Manganese dioxide forms the outer region of the cell, with a zinc case acting as the anode. The manganese dioxide surrounds the nail-type cathode collector. It is surrounded by an electrolyte paste, in an absorbent material. The electrolyte paste is made from potassium hydroxide and is mixed with zinc powder, that surrounds the cathode collector nail. A metal nail is used to collect the current. It is connected to the insulated cathode lead at the battery center. The rest of the electrolyte paste and absorbent material is removed from the core of the cell. This is a 9-volt alkaline battery that is used in various electronic apparatus, such as radios and smoke detectors. Again, the casing is slotted in order to remove the outer casing and expose its inner construction. The battery contains 6 separate cells that are stacked like a sandwich. Each individual cell produces 1.5 volts. The 6 individual cells are stacked in series with each other. The top has a cathode connector terminal, while the anode terminal is at its bottom. Each of the individual cells consists of an absorbent pad, saturated with an electrolyte paste, placed between a manganese dioxide and zinc plate. The individual stacked plates are bonded and riveted together, forming a solid series connected stack. The 6 cells terminate into a terminal connector, which is connected to the apparatus. This concludes this video. Watch for more and refer to our technical books 1 through 5 for repair procedures and techniques. Email us at twmenterprises@roger.com or visit our website at twmmediaservices.com. The books and DVDs can be purchased online through amazon.ca.